Test 1, 2, test 1, 2. Hello. There's a little bit of a lag, but it looks like it's working okay. People, can you put in the chat whether you can see and hear me okay? Very low voice. Let me turn it up a little bit. Is that better? Test 1, 2, test, test, test. Okay, let's go ahead and get started. Awesome. Well, thank you so much to the CodeChef community from VIT and inviting me to give this webinar today. I've got about 50 minutes of content. We'll see how far we make it. And then we should have some time at the end for questions. So thank you to Rajat for reaching out. He had seen one of my videos and thought that it might make sense for me to come present to you and talk about how to get started with DevOps, what are some of the important things that you need to know, and then I'm actually going to do some live coding throughout the session, and we're going to do a little bit of Docker, hopefully a little bit of GitHub Actions, build and deploy a website in real time. So hopefully it'll be fun. Hopefully I don't have too many typos, but luckily I have everyone here in the stream to live debug my code if I make a mistake. So if you see a typo, put it into the chat there. So my name is Sid Palace. I'm a DevOps engineer by trade. My degrees are actually in mechanical engineering, but I transitioned into software a few years back and found that sort of this intersection between development and operations was where I found the most excitement and also what made the most sense to me. So for the past few years, I've really been focused on DevOps and cloud infrastructure. I run a website, DevOpsDirective.com, where I write articles. I also run a YouTube channel where I post videos related to DevOps and cloud infrastructure. And you can also find me on Twitter, LinkedIn, etc. And so without further ado, let's go ahead and dive into this. So the first thing I want to do is have you type into the chat various tools, technologies, or practices that you have heard associated with DevOps. And I'm going to sort of draw them out on this screen here. And so what types of tools do you work with or have you heard of in terms of development or operations, and where do you think they fit within the spectrum? The chat's a little delayed, so I'll precede it with a few. For example, a lot of people, when they think of DevOps, they think of Docker. They're not synonymous. You don't have to be using Docker to be doing DevOps. But I would say that that one falls sort of somewhere in the middle here, because it can be used both for development and sort of working on your system. You can use Docker, but also it enables this really clean operational model where every system that you're building is a compact, self-reliant bundle that has all of its own dependencies. What about continuous integration? So sort of the process of building and running tests against new code before you deliver it. Where does that fall on the spectrum? Oh, I see in the chat, servers. So servers, I'd say fall more, oh. Sorry, I'm streaming from my tablet to my computer. So let's see if we can get that going again. Servers definitely fall more on the ops side, where that's where we're going to deploy our code to. And and that may be running a server on premise. So in the site of my business, I may have a physical server there. It may be in the cloud at GCP or AWS or Azure. So that's definitely more on the ops side. Jenkins is a good one. Jenkins is a tool for running pipelines for like doing your integration tests, building your code, and potentially deploying it. So I would say that falls kind of here, further on the ops side, but a little bit of dev as well. Docker, Ansible. Ansible is a good one, another sort of infrastructure as code or configuration management tool. I would put it here somewhere. And then on more of the dev side, if we just think about sort of the different languages or frameworks that people are using, so this could be your IDE. So in my case, VS Code. This could be something like Node.js or Django or whatever framework you're using to build and deploy your apps. And so there's all of these different technologies. And so that's why I wanted to bring up sort of, you don't have to be using all of these. You want to figure out the right set of technologies. And really DevOps is all about bringing these two practices closer together so that you can iterate faster and faster. Cool. So how does Amazon Web Services define DevOps? They define it as the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. So I think the key element here is this high velocity piece. We want to figure out where we can apply automation or what practices we can implement within our teams so that we can iterate on our code faster, because it's all about building new features and releasing those features, but also ensuring uptime so that we don't break our app and have our end customers have a poor experience. And so DevOps is really all of those things coming together to enable that that type of flow and that speed of delivery. Cool. And so what's the agenda for today? You may have noticed that this is not a normal presentation software. This is actually a website. And so the goal for today is going to be to build and deploy this presentation in real time. And so this presentation was created with Markdown is where the data lives. And then there's a JavaScript framework called Remark.js that takes that Markdown and renders it as this nice web page. And so we're going to start from scratch with just that Markdown file. And then we're going to do a number of things. We're going to pull in that JavaScript library. Then we're going to serve it locally from our laptop. So that's sort of part one. So at that point, we'll have this presentation running with a simple server local. Then in part two, we're going to actually use Docker to containerize that and package it up so that we can deploy it into the cloud. And so I'm going to provision a virtual machine on DigitalOcean. And then I'm going to deploy it to a URL at CodeChef.devopsdirective.com. So once that's live, you'll be able to go into your browser and actually view the same presentation there. And then depending on how much time we have at the end, I'll also try to set up continuous integration, continuous deployment with GitHub Actions. So that'll be a GitHub repo that contains this code. And when I push to that repo, it will rebuild that Docker image, push it to Docker Hub, and then redeploy it to that DigitalOcean VM. And so there's a lot to do. We'll see how far we make it, but feel free to ask questions in the chat along the way. And then I'll also try to just, explain each step along the way as we go. And so here's kind of the rough rundown of what we're going to need to do. Cool. All right. Hello. So, like I said, we have our Markdown file. So this is just all of the data that makes up this presentation. It doesn't look very nice though. We want to pull it in and make a nice looking presentation from it. Luckily, there's this tool, here's the GitHub repo for it, called Remark. And it's a JavaScript library that you can load into your web page. And that will take that Markdown, if you've applied it with the right structure, and turn it into a nice presentation. And so I'm just going to grab this boilerplate HTML here. So it's about, I don't know, 50 lines of HTML. I'll create a new file, index.html. Okay, so this is a basic HTML document. We've got a few styles here at the top. And so I'm going to copy these, and just to clean things up, I'm going to actually move them to their own CSS file so that they're not in my HTML file, just because that's a little easier to manage. So I will cut here, remove these style tags. We're going to create a styles.css, and we're going to save those styles there. Great. So that is out of the way. Then we need to link that style sheet in to our HTML file. Href to point to it equals styles.css. Close that. And then in this default boilerplate template, they actually include all of the markdown right here in the middle. So I'm not going to do that. But first, let's just test and make sure it works. So the easiest way to do that is going to be to run a web server locally, right? I could open this index.html in a browser, but it would not necessarily render properly. If I put it behind a web server, it will know to load all of these other resources as it would for a web page. So the easiest way to run a web server locally on Mac OS, for me at least, is to run it with Python. So I'm just going to do Python 3, and then -m for module, and then the HTTP server module, and that will, I need to go into the presentation folder where those files live. And so that will open a web server on port 8000. And so here I was running this before on 8001, but now I'll go to 8000. And here we just see that title, agenda, introduction. Awesome. And so instead of this, I'm going to pull this out, so we no longer need that text area. And then within this create function call, we can do source URL, and then this is going to point to that markdown file from before. And then if I reload, we get our website. Cool. So we're back to where we started, and we have just completed part 1. So we took our markdown, we pulled in this JavaScript library, we cleaned it up a bit by pulling out the CSS into its own file. We pulled out the markdown, the content into its own file. And so we have this very simple website here that represents our presentation. I'm just going to check the chat and see if anyone has any questions. It is very useful to know about how websites are built in order to be able to be effective in DevOps. So oftentimes, if you are working in DevOps, you will be helping the developers to deploy their code. And so whenever anything goes wrong, you need to be able to dive in and sort of help debug, because sometimes the issue is going to be on the application side, sometimes it'll be on the infrastructure side, and having knowledge about both enables you to better figure out what's going on and to debug the potential issues. The difference between cloud and DevOps. I would say that DevOps is more about how you implement things as a team, and cloud is where you actually deploy to. You will have cloud knowledge as a DevOps engineer, but you don't necessarily need to use DevOps to work with the cloud. You could do everything manually via the console. It would be bad practice, but you could do it. Awesome. So for part 2, we now need to figure out how to take this code and get it onto a server, onto a virtual machine, running in the cloud. And so the way that I'm going to do that is with a web server technology called Caddy, which is a pretty cool piece of technology because it actually handles setting up your TLS HTTPS certificates for you. You just configure it, and then when you launch this server, it'll actually go off and get your certificate so that you can serve over HTTPS. We could use something like Nginx, or there's plenty of other servers available, but I just really like using Caddy because it helps set up HTTPS automatically. In order to do that, though, I could just run this locally, and then I could run it on the web server and push the code there. But the reason that I'm not going to do that is if as you get a more and more complex setup, it becomes harder and harder to ensure that all of the dependencies, let's say on my local MacBook, can match the dependencies on the Ubuntu machine that I'm going to deploy this onto. And so you can really get yourself into a challenging situation, sometimes called configuration hell, where you have different versions of different packages on one system versus the other system. It works fine on your laptop, but then when you actually try to deploy it to production, you have issues. And so in order to prevent that, we're going to use a technology called containers, and specifically a software called Docker that's going to build and run those containers. And so in order to do that, I'm going to create a Docker file. I'm also going to create a make file, and I'm going to create a caddy file. So a Docker file is how you define your application and all of its dependencies so that you can build it into what's called a container image. That image we can then run as many copies as we want, wherever we want, and it will be identical each single time that we run it. And so the way that we do this is we start from some base image. And so this could be something like from Ubuntu. And this would then give us a base image that has just a bare bones Ubuntu installation. And then we could go through and install all the necessary dependencies, copy in our source code, etc. And so in this case, caddy has a Docker file already built by the people who build caddy themselves. And so I can go here on, clicking around. Here's this official caddy image on Docker Hub. So that's the one that I'm going to start from. So this already has lots of all the necessary dependencies and configurations to run caddy. And so I'll just do from caddy, and then this latest version is 2.1.1. And so then from there, what do I need to do? I need to copy in my configuration. And so the way that you configure caddy is with this caddy file that I haven't authored yet, but I will in a second here. So I'll do copy caddy file, and I'm actually going to name it local because I'm going to have a production version of these in a minute here. I'll make this local as well. And so the syntax on this one is I copy a file from my host system, so that's my MacBook, into this container image. And so the location that caddy is going to be looking for this config file, the default location is just this .etc/caddy/caddy file. So if I run that, when I build it, it's going to take this local file and put it into that container image. Once I do that, I then need to copy in my actual presentation files. And so those presentation files live, and I think these are at the wrong level. Yeah, move. So I want these outside of my presentation folder. Okay. So I'm going to copy in those files. And so ./presentation is where they live. Presentation. And I'm going to copy those into this serve directory. So that will take all of the files within here, so including the images, including my home page, index.html, my styles, and my markdown. So that'll copy everything into this location within the container image. And then finally, I need to expose a port. So I'm going to be running this on port 80 and eventually on port 443. Cool. And there we go. Actually, the local version I don't need to run on 443. I'm just going to run on 80. So 80 is the conventional port that you would run a non-secure HTTP server on. 443 is the port where you would generally have HTTP requests coming to. And so in this case, locally, I'm only going to run it on port 80. We need to create this caddy file. And so caddy has a number of different ways that it can be used. I'm going to be using one of the most simple ways, which is just as a basic web server. And so the way that we define this is we pass it the domain that we're going to host it on. And so that is going to be localhost on port 80. We then have root star / serve. So this just sets the root directory within that caddy file to be that SRV directory where we copied in our files. And then finally, we'll use this file server directive, and that just tells caddy to act as a web server essentially. And so that is really all the configuration that we need in order to build and run this local container image. I'm going to use this makefile as a way to sort of store off all the different commands that we're going to use throughout this. And so a makefile uses a Unix utility called make, which is used to build code. Traditionally, like a compiled language, you would have all of your different make targets to build the different source codes into the runnable executables. In this case, I'm just sort of storing off a bunch of scripts that will get called as we go. And so this will be like build local. And so in order to build that container image, I need to do docker build, and then I can tag it with, let's say, presentation. And then I'm going to pass it this file. And so it's that local Docker file, and then a period, meaning that we're going to build from our current directory. And so if I do this, make build local, no such file. Oh, I have a typo right here. So it was saying my Docker file didn't exist because I had a typo. And so if I do make build local, it calls docker build for this Docker file. It's going to tag that image with the title presentation. And it looks like it successfully ran. And so now we have this container image on our system, and we want to instantiate a copy of that. And so in order to do that, we're going to use the docker run. This will be run local. And so this will be docker run, and then we pass it that name, presentation. We want to run it on port 80, like I said. And I'm gonna do this. So this syntax, this -p says, when I do this docker run command, take all of the inbound network requests to my local host, which is my MacBook, and forward them from port 8080 and forward them to port 80 inside that container image. So that'll allow me to, within Chrome on my system, issue a request that'll make it into that container. Otherwise, it would be isolated from the outside world, and that Docker container would sort of live as its own thing that you couldn't access. And so I'm going to do that, make run local. And so it should now be running on localhost. And I'll do this in a browser, localhost 8080. And so we get the same result. We are able to see our presentation within that caddy web server container. And so we're kind of building layers, right? We first built our website and we just served it with that Python web server. Now we've created this container image that we'll be able to take and deploy onto a virtual machine in the cloud. And because we're using containers, we're going to be confident that it's going to run the same locally as it does remotely. And so that gets us to part 2, step 1. We just Dockerized our image with caddy, so that is good. And so now we actually need to provision a server so that we can deploy to it. And so I'm going to do that with DigitalOcean. So there's many different cloud providers. The 3 big ones are AWS, Microsoft Azure, and Google Cloud. DigitalOcean is another up-and-comer. Linode is another up-and-comer. They're slightly less expensive. They don't offer quite as broad a suite of services. And so in this case, I'm just going to use DigitalOcean. They have a really nice pre-configured virtual machine with Docker already installed and configured. And so that'll enable us to get up and running very quickly here. And so I'm going to do this through the browser. Ideally, if we were following a DevOps methodology, you don't want to do anything manually in this way, because anytime we go through and we click a bunch of buttons, that's a potential area for mistake. Ideally, we would define this infrastructure as code, so it would live with our code base so that we could have everything defined and be able to provision all of our infrastructure automatically. We don't have time for that today, so I'm just going to provision it manually, but I wanted to call that out as sort of a way to improve this or make it more DevOps friendly if we wanted to. And so I'm going to get started with Droplet. This marketplace option is where we can find the Docker image that I was describing. So this Docker on Ubuntu image, shared CPU, basic. This shouldn't require much at all, so I'm going to use the cheapest VM here with one CPU and a 25 gigabyte disk. That should be fine. It's going to provision in New York. All looks good. I have my SSH key already set up. And so now if I just click Create Droplet here, it is provisioning. This usually only takes a few seconds. We now have our IP address. So this is the IP address of that server. So this is how we're going to connect to it. And so I'm actually going to store this as a variable here. VM IP, and let's just save it there, because I'm going to use this down the road in a few different places. And so the other thing that I need to do here within DigitalOcean is going to be to add a firewall rule to it. So I think by default, I would be able to connect. I don't need your survey right now. Satisfied. All right. No, I don't want your survey. Okay. I'm going to add a firewall to it so that we'll be able to access this web server with HTTP. So as you can see, I have ports 80 and 443 added here, and it's going to accept requests from any inbound IP address. I also have SSH on here because that's how I'm going to connect to the server to deploy to it. So that should be fine. I now just need to add that droplet that I just created. And so that is good. Cool. I think I'm done in terms of the DigitalOcean part. I now need to take my the URL that I want to point to this IP, and the way that I do that is with a DNS A record. And so DNS is how you take a domain name like google.com, and it uses DNS to look up which IP address that should correspond to. So in this case, I'm going to set up CodeChef.devopsdirective.com, and it's going to point to the IP address of that server that I just created. So I'll save that. And so now CodeChef.devopsdirective.com points to that server, but there's nothing running on that server yet. So we need to take our image and deploy it to that server. We need to do a few things before we're ready for that though. This version was this local version, right? Where I'm only serving on port 80. I'm only serving on localhost. So we're going to create a new file with the proper configuration to deploy to that remote server. And so here, I'll just do caddy file and Docker file. The Docker file is going to be pretty much identical. I'm just going to add one line, expose 443. So now we'll be able to not only serve on port 80, but also on 443. The caddy file is also going to be quite similar, but we're going to modify two things. We're going to change this to be CodeChef DevOps Directive.com. Okay. And then we also need to set tls.palace@gmail.com. So this is the email address associated with that I used to buy this domain name. And so it's going to look up when it provisions those certificates, it needs to match the address that I provide it. So that should be good. Let me see here. I then need to build and push this image. So right now I'm building it locally, but I want to build it and then push it to a remote repository such that from my virtual machine, I can then grab it. The most common place to do that is a site called Docker Hub. There are other repositories as well. I think all of the major cloud providers have a container image repo. So Google has Google Container Registry. I think AWS and Azure have equivalent ones. But I've gone ahead and created this repo within Docker Hub. So this will be a public image that I can push to, and then I'll be able to pull that image onto my virtual machine when I want to run it. So first, I want to build production with a T. It's going to be a very similar command to this one, except now we're going to, this will be using this as our tag. So it needs to match this so that Docker knows where to push it to. And I'm just going to call this latest. It's fine. And so now instead of presentation, I'll substitute in this image tag. And instead of local, we'll just use the regular one. And then instead of running it, what we're going to do is actually just push production. So here, we're going to do Docker push, and then that image tag. All right. So I now have these two targets. I'm going to run the first one, make build production. And so that's going to run my Docker build command with that specific Sid Palace / DevOps Directive CodeChef tag. And so we've built that image and we've tagged it. And now if I do Docker push, because I'm authenticated to Docker Hub already, it should, let's see here. So here we see that I last pushed this 10 hours ago when I was testing this. But if I do make push production, it is pushing. And then if I refresh over here, once that completes, we should get a new image here. A few seconds ago. Awesome. So we now have this latest tag version in Docker Hub. And so the next step is going to be to actually go onto that virtual machine. And run it. So here we want to SSH onto that virtual machine. And so it'll be SSH root at, and we're going to use that IP address variable that we saved off before. Yes. And so now we have a running shell session on that machine. And so we need to just issue a Docker run command with our tag. So it'll be something like Docker run. We want to port forward 8080. So from the host 80 to the container port 80. We also want to do the same for 443. And then we need to do a couple of additional things. We want to have a volume mount. So the interesting thing about containers is because they're isolated, any files that you save within them, if you restart the container and you delete the previous container, those files are all going to be gone. So one way that we can get around that is by mounting in a volume, it's called. So we'll essentially take a directory on our host server and mount it into the container so that those file systems are shared. And we'll be able to save a file within that volume that will persist beyond restarts of that container. So here we're going to use the caddy data just at the root of our file system, and we're going to mount that into /caddy, /data, which is where caddy is going to store its data. And then we'll also have -v for caddy config, and that will store in the config directory. And then finally, we want this image tag is the image that we're going to run. And I'm going to add one more command here, or one more flag, and that's the -d flag, which will run it in the background as a daemon. So if I don't do the -d flag, it will stay attached to my session, but I actually want to run it so that it is running in the background, and I can go off and do other things, and it will continue running. Okay, that looks good. I'm just going to copy that and run it on the server, and we'll see what happens. Unable to find the image locally, so it found the image then, and then it ran the image. So it went off to Docker Hub, it downloaded it, it then started the image, and if I do docker log and then this ID, docker logs, excuse me, we can see that it is starting up that server, and it's doing the HTTPS certificate maintenance. So it'll take a little bit. And then once that is done, we should be able to go and check on our server and see if it actually provisioned properly. Started server certificate maintenance routine. I think I made a slight mistake here. Docker PS. So I'm going to kill this, Docker stop. If you'll notice, in my Docker file, I didn't change from local to regular, and so it was trying to use this configuration rather than this configuration. And so now I will exit, and I will rebuild and repush that image. And so that new image should have that updated change. So here in my Docker file, I'm now copying in this caddy file rather than the local caddy file. I will have done that. Cool. Now I'm going to make SSH. So I am back on that server, and I'm going to pull the latest version of this image. Great. And then I'm going to rerun this command. And now, hopefully, Docker logs. Okay, so now it got that authentication challenge from the Acme server. It is going to try and combine the information that it knows about my email address with that domain and see if it can issue a certificate. It can take a few seconds. Uh-oh. Cannot authenticate. CodeChef.DevOps Directive. Should be fine. CodeChef.DevOpsDirective.com. So there is a potential to get rate limited from the authentication server if you try too many times. So I'm going to stop that container to try and avoid that. And then I'm going to look closely at my configuration real quick and see if we can figure out what's going on. So, that all looks fine. Expose 80, expose 443. Okay. This is what happens when you live code. Anyone who is in the chat who sees the mistake I made, feel free to let me know. CodeChef latest. It all looks fine. So I'm gonna do one thing. I'm gonna change this to like v0.1, just so we have a new tag to make sure we're getting the new image that we want. We are here. Looks good. So I'm going to try one more time to redeploy this. I'm going to remove this -d flag so that we can trail the logs. Did I get my IP address correct here? 104.236.4.10. Looks good. Oh, okay. So it looks like we succeeded that time. So I'm not sure what happened the previous time. But now I'm going to go here. And because Caddy automatically encrypts all your traffic, you actually have to have this full setting on Cloudflare so that the requests come from Cloudflare to Caddy with the HTTPS enabled. So now, if everything worked, we'll just go to CodeChef.DevOpsDirective.com, and there we go. So this site is now live on the internet. You can go to it in your browser and see this presentation deployed. So we got there just in time. We've got a few more minutes. I'm going to try to go ahead and get the continuous integration, continuous delivery set up with GitHub Actions in the next 10 minutes or so, and then we'll have a few minutes at the end for questions. Cool. So that was sort of the process of manually deploying to a virtual machine. That is not a very scalable process. Let's say we have a whole team of people. With each change to the code base, I want to automatically run all my tests, build my image, and push that image and deploy it to the virtual machine. And so the way that we do that is using a process called continuous integration for the building and testing part, and then continuous delivery or deployment for the deployment of the image itself. And so what I'm going to do here is create a GitHub action. And the way that we do that is with a .github folder and then a workflows folder within that. And then we can name this whatever we want, but build, push, deploy. So any YAML file within this directory will get picked up and run as an action workflow within GitHub Actions. I have already created this GitHub repo ahead of time, Sid Palas / Intro to DevOps webinar. I haven't put any code in there yet, but I did go ahead and put a couple of settings, a couple of secrets that will be used within that GitHub action, including a token to authenticate to Docker Hub and an SSH key to authenticate to that virtual machine. And so those are the only things that were sort of pre-populated within this repo. Okay, so within the workflow, there's just some boilerplate code that we can start with. And so that is going to be the name of the workflow itself, and then the trigger event. So every time we get a push to the main branch, we want to run this workflow. That looks good. And then we need to define the job itself. And so the way that we do that is with this. So here we're going to have a set of jobs. The first one, and we're only going to have one, is going to set things up, it's going to build, it's going to publish, and it's going to deploy our container, and it's going to run on Ubuntu. So that's the underlying operating system that all of these steps will execute on. We are going to have a number of steps here. The first thing that we need to do is to install our SSH key. So I stored it as a secret within GitHub, but we need to configure it within this Ubuntu virtual machine where this workflow is running. We need to put it in the right place and configure SSH, the SSH software, to be able to use that key properly. So I went and searched for an action that could help do that, and I found this SSH key action here. It uses the SSH key secret, and then we also have to create this known hosts secret as well. And so for this one, this step is going to use that syntax. The name of the step is going to be install SSH key. We're going to use that action. So this is the syntax here. We can find an action on the marketplace and just use it directly within our workflow. And then we need to configure these two things. I already configured this one, but the known hosts one, we actually need to get the host. There's a public key associated with that server that needs to be in the known hosts file within our system. Otherwise, SSH won't connect to that machine. And so we are going to run a particular command. Let's see. We run this SSH key scan and get the RSA key for this particular machine. I then need the IP address, which I have stored here. And so this is the public key from that machine that I will copy into my known hosts secret on GitHub. So I'll just copy this, then we'll go back here. We want settings, secrets, okay, so that should be fine. So hopefully that step should now be able to run. The next step that we want is to be able to log into Docker Hub because we need to push the image like we did from our local system. And so for this step, we use another public action, so this Docker login action. So I found this on the marketplace. It will take in our username and token. So I generated a token from Docker Hub and stored that as a secret. I then put in my username as a secret as well. So that should be good to go. And then for our build, publish, and deploy steps, we're actually just going to use our make targets. So first we need to check out our code. So this is a step that's going to be in almost every GitHub workflow. And that is just to check out the version of the code associated with the event that triggered the workflow. So this will clone our repo essentially and get that version of the code to operate on. We then will have a step called build. And so within this step, I'm just going to run the make build production make target that I created in my make file, and that should build the image on within this workflow. I then will have one called push, and that is going to run the make push production. And I will have a deploy step, but for now, I'm just going to have these and see if we can get that running properly. So we have make, push, great. So I'm going to commit all of these. Oop. Then I'm going to push. I haven't pushed yet, so I have to set the origin. Okay. So now if I go to the Actions tab, we should see that initial commit. Yeah, so because I had that .github directory with the workflows, anything in there that is a YAML file will get picked up. So we'll see that workflow running here. It looks like the SSH key installed successfully. It looks like the Docker logged in successfully. We built our container. We are now pushing it. And so if I go back over to Docker Hub and I reload, the tag that we used there was v0.1, and it was pushed a few seconds ago. So now we have it set up so that every time we push to that main branch, we will get an updated version of our image in Docker Hub. So the only step that remains is to add one more step to our GitHub workflow, and that's going to be to deploy that image to the virtual machine. And so we're going to have one more. It's going to be deploy, and we're going to define a new make target called run remote. And so what run remote is going to do, it's going to issue an SSH command to that server to start it. And so here, this one I'm just going to copy in because it's relatively complex. We're going to do a few different things. So first, we're defining this make target. And so this says SSH root at that IP and send this command. So if I add a command after the SSH command, it sends that to the remote machine. So for example, I could do SSH root at, what's my IP address? And then I could do ls, and that would just list the directories and files within my home directory on that machine. And so here, instead of just this simple ls command, I'm going to be sending those Docker commands to start the old image, pull the new image, and then start the new image. And so this effectively takes in whatever I set as my command environment variable and will run that command on the remote machine. And so I can do this, I can use this SSH command make target with this environment variable. So this is saying run docker pull image tag on the remote machine, then do docker stop to get the old image and stop it from running, remove that old image so that I can create a new one with the same name, and then I will run my docker run command here, which is fairly complex, but it's basically the same thing as before. I've added this tag such that if something were to happen and it went wrong, Docker would automatically try to restart. Otherwise, everything is pretty much the same. I am going to make one more modification to my image tag, and that is going to be a little bit hacky, but it will work. Basically, we'll just call this latest. So this GitHub SHA is going to be the, when I run it locally, it'll just be latest. When I run it in the GitHub workflow, it will actually be equal to the commit hash of the commit that triggered the push event. And so that will enable me to change the tag each time so that I never accidentally leave the tag the same and end up running a version that I didn't want to run. So I think we should be good to go here. I'm going to test it locally with make build production. Make run, make push production. Okay, so we just built and pushed our latest image, and then I'm going to do make run remote, and it's going to grab that latest version, stop the previous container, and then start a new container. So hopefully, like let's go here, and I'm going to change my presentation slightly. We're going to get excited in Markdown MD. We're going to add some exclamation points here, and then we're going to do make build production. Make push production. My internet is going slow. And then we're going to do make run remote. Uh-oh, port is already allocated. So what happened there is I think my initial deployment wasn't named because I forgot to use this, or I forgot to specify this container name. And so I need to have a container name here. Cool. So yeah, I forgot to name the container. So then the docker stop command didn't work. And so it still was running there in the background. And so it was unable to connect the port together. And so I'm going to do, now that I know that command basically works, I'm going to go ahead and commit this all. And so this is still the same. We're going to commit everything. And so we will see, but ideally that will kick off our GitHub action, which will build our site, deploy a new version of that site, and then we will be able to look at it and see the updated version with those exclamation points on the live version. So while that's running, I'm going to hop over here to the chat. Thanks for linking the repo and the site within the chat. Can we use something other than GitHub Actions? You can use all sorts of different CI/CD tools. Many of them have integrations with GitHub. So I've used Circle CI, which has a pretty nice integration with GitHub. GitLab is sort of an all-encompassing suite of tools that has your version control system, which is Git, but also has an integrated issue tracker, an integrated CI/CD tool, etc. So there's lots of different tools you can use with GitHub or without GitHub for doing CI/CD. Kubernetes did deprecate Docker, but only as the runtime. So the only part of Docker that Kubernetes needed previously was the ability to run the containers, because you're not building them within Kubernetes. So containers built with Docker will still execute just fine within Kubernetes. Even once they remove it, because they conform to the open specification. It looks like that succeeded. And so let's go here and refresh, and we got all those exclamation points. And so just over time, I'm 3 minutes over time, but we were able to create this website locally. We then Dockerized it. We then deployed it to DigitalOcean, and then we set up continuous integration, continuous delivery, so that any changes we make, we can just push them to the GitHub repo, and they'll automatically get integrated and deployed to that site. So that's just, I went pretty quickly, but that sort of touches what an end-to-end workflow within DevOps looks like. We first are working on the dev side, creating our website, creating our application. We then need to figure out how to take this application and deploy it to our remote environment. And one great way to do that, to ensure that stuff is going to work how we want it to, is to use a technology like containers. We then set up our GitHub action workflow to automate the process of taking new code updates and getting them live to our end users. And so that sort of concludes the full walkthrough of what I wanted to do today. Hopefully that gives you a taste of what some of the elements of DevOps are. Like I said, there's lots of different tools. There's lots of different techniques. This is one particular workflow, so you want to figure out sort of what works for you and for your team to make the process most effective, so that you can deliver faster and higher quality software using these types of techniques. Let's see, a couple of questions in the chat around monolithic applications versus microservices. I think that oftentimes you start with a monolith because it is just easier. Your application is not that big to begin with, and so you start with a monolith, you build it out, and then when you reach the point where everything is so intertwined that it's very difficult to add new features and make modifications, then starting to pull things out into their own dedicated microservices can be a powerful technique to further increase your code velocity once you reach that point. Which event bus do you prefer and why? I don't have strong opinions on which event bus is best, so I can't offer an answer there. But unless others have additional questions in the chat, I will probably sign off soon, now that we've reached the 1 hour mark. Again, thank you so much to the CodeChef community for having me. Hopefully this was a helpful introduction to DevOps. Feel free to reach out to me and connect on LinkedIn or Twitter. Find my YouTube channel. Would love to have you all part of the DevOps Directive community. And so with